Well, good day, everybody, and thanks for joining us. And a special thanks to Craig McLean, who I've known for probably better than a decade and a half, and really appreciate, Craig, you taking the time to share your perspectives on the UN Decade of Ocean Science, particularly like the title, if you like your 10-day weather forecast, like an oceanographer. Craig has served NOAA for 40 years. More than half of that, he was in uniform on ships and served the oceanographic side of NOAA. He joined the executive ranks and became an assistant administrator for the Ocean and Atmospheric Research. Pretty well up to close to his retirement, where he served as the acting chief scientist for NOAA. And so again, thanks, Craig, and over to you.
David, thank you very much, and good day to all my friends up north. I appreciate the invitation and the opportunity to charm you with the title that I've chosen here. And I have to say that in a previous talk, I used this same theme of, if you like your blank weather forecast, thank an oceanographer, not to denigrate or any way deny the skill of our weather service forecasters. In fact, I've always been an advocate for the professionalism of our weather service forecasters, but also the researchers that stand behind it. But an interesting time passed when I gave this talk. I used to say, if you like your 7-day weather forecast, thank an oceanographer. And people had reminded me that even that 7-day forecast, pretty much globally, has been enhanced to the point now where people are investing their faith and reliability in a 10-day forecast. So I hope to share a little bit with you on my perspective of the UN Decade of Ocean Science for Sustainable Development. And if there are any among you in this community who aren't aware of that decade, I will at least have accomplished one goal, which is to further socialize the fact that we have a UN decade ongoing now. Now, if you do follow the UN closely, you're probably unique among the audience, but there are many decades that are often happening simultaneously. But this is one that I feel is very important to our community, the ocean, the atmospheric, the meteorological community, because it's focusing on an opportunity to globally leverage investments, to globally enhance capacity development into those parts of the world that aren't benefited from the economies that Canada, the United States, Western Europe generally enjoy. So we'll go down just a little bit of a tour here, and I'll start with what I would call the wonders of the ocean. I'm an ocean guy. I was raised on turned out to be one of the 10 most polluted rivers in the United States. That's not any nobility, but I was always thrilled with oceans, and it had a sense of excitement and discovery for me. What I did with that was, in between college and coming to join NOAA, I found the best visibility I possibly could in the urban New York and New Jersey areas, and spent a little bit of time diving in zero visibility in industrial diving. I pretty soon realized that this was not for me, so I'm hopeful that you could see that maybe there is some wisdom in the mind of this guy who's speaking to you, that I got out of this world after paying off my college bills. But it was a wonderful experience in leadership and a bit of an adventure diving in zero visibilities in the most urban rivers and some interesting places offshore. But let's contemplate the planet now. And I really love this blue marble image that comes to us from NASA. As you could really see, the Earth atmospheric circulation marked, at least in the visible range, by the clouds that we can see here. And to realize that that Earth-sea interaction is what drives climate. And as we know, we are in a climate crisis as we're approaching those temperature thresholds and tipping points that accompany them, both for the ecosystem and for the world that we've come to know and acclimatize ourselves to, if you will, for the past 6,000 years. And that's really all changing pretty rapidly now. But the idea that inspired me was the adventure of the ocean. Soon I then discovered how the oceans drive weather, how the oceans then drive and define climate. And it's what you folks in your society have focused on throughout your career. It was a gift to me because it's not where I intended to go in mine. So as we contemplate that planet, further contemplate this image that comes to us through the U.S. Geological Survey and the Woods Hole Oceanographic. basically what we're looking at here is, I'm sorry for this little intrusion. I don't know if I could get rid of it. There we go. What we're looking at here is the volume of water on planet Earth. And the Earth is physically so large, and the volume of water that we have to manage and deal with is actually quite small. So these two spheres represent with accuracy in a relative proportion how much water covers the Earth, salt and fresh. And it's remarkably little. But when we can consider the complexity that this drives, being that fluid that's circulating on the earthen mass, it's a remarkable consequence. And it reminds me that that polluted river that I grew up on, I could understand because I was so close to New York City, how humans could pollute that river. But could I really fathom how the world population right now, about 8 billion people on this planet, by the end of the century, it'll be 10.4 billion people. Could we have an influence on the nature, the quality, and change the chemistry of that volume of water? Heck yeah, with that number of people. But until you look at it in this perspective, it's not necessarily the first thing that would come to mind. The ocean appears to be so great and large and huge. But the reality is, in a relative mass, this is what we're really looking at. Now, we also look at the scale and scope of our atmosphere. Jump in your car and get on a highway and travel 60 miles an hour. And in an hour, you will have transited the depth of our atmosphere. It's very shallow. It's really a thin layer. Once again, given the population load of the Earth, we're having this effect on the planet. And it is not irreconcilable that our population load could be influencing the formerly naturally occurring mix of the atmosphere, so that we're now pumping greenhouse gases into the atmosphere, insulating and heating up the planet. So with these problems upon us, let's now travel to what you're probably familiar with looking at, but maybe it could be in a slightly different level of approach. Go back over the past 400,000 years on planet Earth, and you could see the CO2 levels from, if I can move my cursor to starting at 400,000 years ago, you could see the CO2 levels have been variant, but they've never exceeded a threshold of about 300 parts per million. These rising and falling levels of the planet generally correspond to the wobble of the Earth. The Earth does not wobble that much more rapidly and have that much more of effect. But as we start to look then at where we've punched through this 400,000 year norm of the highest level of CO2, we have greatly and boldly exceeded it at this point. So what are the consequences of that? When we start to look now at the CO2 where we just left it, and please know this is a dated diagram, but because the CO2 is changing quickly, this was prepared by John Englander in his excellent book that talks about sea level rise. So I would refer you to John Englander's work in a very easy to understand lay discussion about sea level rise. So if we look at how the CO2 has punched through that threshold and is on a rapid march northward, you then look and see what the average global temperature was in the next layer down, and in the red, as you could see, and they mirror each other. And casual scientific observation, casual lay observation sees the correlation between these two. And then if you look at sea level, you realize that both the CO2 level, the global temperature, and the amount of ice that we had on this planet correlates nicely in its match. And we realize that where we are right now, at the rising level of the sea, at the rising global temperature, next one up, and at the level of CO2, if it stayed at around that 300 level, we'd be ready to see a downturn in temperature, in CO2, and in sea level. So we should be heading more towards another ice age in geological time. Instead, we're getting warmer and warmer and warmer. So this problem is one of constant concern. But what I'd ask you to consider is we have good reason to believe that with warming, we have a lot of heat in the system. It's going to further melt the ice. Some people are going to have their ankles wet on the coast. Some will have their thighs or their knees wet on the coast. But right now, we're not sure when and how bad. And I think that's what we need to be focusing on. So if we look at this simplistic ribbon-based illustration of the heat redistribution from equatorial regions towards the poles, and then the subduction up in the polar and semi-polar regions of colder water to bring that water into full cycle, the roughly 1,000-year turn that the ocean currents make for droplets of seawater, we come to realize that what we're doing, particularly in the Arctic areas, is causing a disruption of this. Now, some science has indicated both by model forecast, but also by in situ measurement, that the circulation of this Atlantic meridional overturning circulation, same for the Pacific, same for the Southern Hemisphere, can be seen to be starting to slow. And I think we need more measurements in order to determine the fidelity of that and reality of that conclusion. But the indicators are starting to be seen. So we humans are influencing the stability of the planet that we've come to know. The warming of Europe because of the Gulf Stream waters, the warming of other parts of polar and semi-polar regions because of Gulf Stream waters, and the breakup of the poles, the Greenland ice melt, the West Antarctic ice shelf melting, those are having effects in the physical and then also the biological. So if we talk about the biological, we have millions and millions of people on this earth who are fed by marine-based protein. But that marine-based protein is nurtured in a marine ecosystem that is changing far more rapidly than it did evolve. It's changing far more rapidly than we can catalog, measure, and inventory. So that challenge is boldly upon us. We're not just changing the thermal components as the ocean is warming. As it warms, marine creatures and marine habitats are migrating. And to my good friends of the North, and we love working with you so closely, it'll probably be a gift to the United States that what were the Massachusetts and Massachusetts and Maine lobsters will one day be Canadian lobsters. That migration is ongoing. And we need to realize that we are changing rapidly. And as many people have reported, the marine environment is changing more rapidly than the terrestrial environment. So onward we move. Here's an image that I would ask if you could recollect in your high school or mid grades. This is the illustration that we all saw and that the public understands at the basic level for the generation of oxygen and the absorption of carbon dioxide. And here is what we don't show people: the generation of oxygen and the absorption of carbon dioxide. But the oceans are responsible for better than 50% of the oxygen that we breathe. Now, that's a statement that deserves a wild footnote. Better than 50%. Is it 50.1? Is it 80? Is it 60, 70? Hard to say. We do not have sufficient mechanisms of measure in order to determine that. And we should. We should have the ability to quantify that amount. But as we are today, and as we sit here today, we don't. It's a rough approximation simply because we don't have enough sensing components deployed and distributed around the globe for us to be able to make that determination. Okay, so we define the problem. You're familiar with it. You've worked with it. You've worked in it. And many of you have helped open up the doors of understanding and knowledge that let us see this more clearly. So if you have been in circulation and visited some of the global meetings, the Our Ocean meetings, the Ocean Conference of the UN, the Economist World Ocean Summit, and others, you're very familiar with this list and others on that list of matters that we need to be paying attention to, that the oceans are being stressed by humans, not just that dirty river that I grew up on, but the entire world ocean. Hard to find any place in the ocean that doesn't have evidence of human passage or human impact on it. And the same for the atmosphere, of course. So these commonalities were focused on by folks in the UN body. And we also had the 2030 Sustainable Development Goals. And you could see, certainly for biological diversity or biodiversity, elements of disaster risk reduction. It's not just can we do better to reduce the risk of disasters in the Sendai Protocol, but it's basically recognizing that we're going to have more of these episodes more frequently. And as they do get more volatile and more damaging. And then, of course, the UNFCCC, the Paris Agreement, and the ability of humans to control ourselves and mind the planet and bring climate change under some measure of control. So all of these factors universally recognized, except for commercial interests that have too overriding a motivation to not recognize them and have rather subversively planted misinformation into the public discussion. But if you look at the pure science and see where this really has led, the commonalities are everyone's discussion. What then came to the ocean science community in the Intergovernmental Oceanographic Commission was the idea of creating a UN decade of ocean science, but to incorporate the Sustainable Development Goals and to make the purpose of the science for sustainable development. And upon the creation of this, I'm grateful to have been provided the opportunity to be involved in helping to formulate this UN decade. As I mentioned, there are many UN decades. And the body that was proffering this, the Intergovernmental Oceanographic Commission, proudly represented by a strong Canadian delegation routinely. I spent 11 years with this body as the US representative, and there were many countries of leadership, Canada, UK, United States, Australia, Germany, France, Japan, the countries that you would probably expect based on whether you're an oceanographer or a meteorologist, the people that you see a lot of participatory talent being offered. But the idea was not, and we had to fight with this a little bit, the idea was not to have a decade of science and then generate 20,000 science papers that were of interest to 20,002 people. Someone's mom and dad probably got in there and they would read them too. The idea was to make the science targeted towards what communities need, and in particular anticipating that, as I mentioned earlier, by the end of this century, with 10.4, 10.5 billion people on this planet, compared to the 8 billion we have today, we're going to be in a very different circumstance. Energy demands are going to be higher. Population density is going to be higher. So put all these together, it was important to come up with a decade that would invite international collaboration, cooperation, philanthropy participation, commercial participation, and it's off and running, and it's starting to work. But maybe just a little bit more about the decade here. If you can contemplate the excitement that the ocean science community had, many of you were part of that, and I want to commend our friends up to the north. I want to recognize and commend Anya Waite with the Ocean Frontiers Institute, because Anya hosted the North Atlantic workshop. Maybe some of you were at that, as we planned these regional workshops around the globe, northern and southern hemisphere, the small islands, developing states, the parts of the country, including Africa, that are normally, unfortunately, overlooked, but very important to our global balance. But we developed and prepared an implementation plan. I'll cut to the chase on this and just remind you, if you look in that right-hand column, the 10 areas of focus that have been identified and organized for where the UN Decade of Ocean Science is headed. These are the components that are being worked on. In the center, you have the ambitions that at the end of the decade, the desire would be to provide a clean, a healthy and resilient, a productive, predicted, etc., ocean. And I particularly like the inspiring and engaging, because we science-minded people are not the only ones that need to be participating. We need to excite the public about this. So as a result of these global workshops and open solicitations for ideas from scientists who are deliberately informed by societal need, not just neat science, we came up with, and here we are today, with 276 projects organized under 48 programs. That's astounding. It's really, really astounding, and it's exciting. So I offer for you here the web address where you can go on and look and become more familiar with some of these projects and programs. What is equally astounding to me, if not challenging and disappointing, is that the vast, vast majority, more than 50.1%, nearly 90% of these projects don't have funding. They are keen ideas. They have been reviewed and endorsed by a review panel of global experts who have assented to the importance of this work. But the funding isn't there, and it's up to largely the governments of the world in order to fund this science, as has been typically the past practice in the past 1 to 2 centuries. We now see philanthropy entering here, and we've worked very hard to try and acquaint philanthropy with what these opportunities and offerings are. And in some cases, organizational money is necessary. In other cases, operational execution money is necessary in order to conduct the actual work, as opposed to organize the meetings and the gatherings of the talented people who would do the work. So I just highlight to you that it's off and running. We're several years into it now. It concludes in 2030. We're getting started, but we do need more advocacy, and perhaps your voices can be heard in your democratic process, as I've been spending a lot of time in my retirement with our Congress to try and acquaint folks with the opportunity of leveraging and the need for this work to be done. So if we look now at those numbers that I showed you, the 276 in the upper left, 276 projects, 48 programs, there are additional activities embedded. I'm not going to bore you with the intricacies of these charts, but I did mention that there was a board that reviews all the submissions. That's this group in the upper right, the Decade Advisory Board. There are distributions of multinational committees and components, and a lot of work going on from this. The reach of the decade will not be our disappointment. I hope we can just get started and sustain those projects that we're looking at. And if you look back, for those of you that have been here, I'm not the only retired chap that's around. If you think back early on in your ocean literature, you may realize that in the 70s, there was an international decade of ocean exploration. Now, that term exploration is a little tricky today because most folks confuse that with looking for energy sources, oil sources. But back then, it was scientific exploration. And that international decade of ocean exploration gave rise to many of the oceanographic programs that we still practice today in global measurements of the ocean, global measurement of the ocean and those components of the Earth system that are dependent upon the ocean. So I'm hopeful to see that the same will result here. Very active, a lot going on, still looking for some funds. Now, I know you're not the group to go ahead and provide those funds, but once again, your voice and advocacy would be very important. So back to 276 projects, 48 programs. How do you distill that down into something meaningful that you could put in the palm of your hand and have an informed discussion with folks? These several ideas were at the very beginning. They're strongly represented throughout the decade, and they distill 276 down to something that's manageable and meaningful. What I'd like to focus on with you today are these three. To map the entire ocean. Hard to believe that we're trying to manage the ocean as a patient. Look at the pulse, the respiration, the blood pressure, et cetera, which would be the observing systems. But back to mapping the ocean, we don't have a Gray's Anatomy. You remember that old text that still is active today and periodically updated to describe the human form physically. Well, now we've got basically the entire DNA of human beings, but we don't have that for the ocean. So we have to map the ocean finally and get a real map of the ocean. You may realize, you may already know, when MH370 went down, the aircraft that was lost west of Australia, south of India in the Indian Ocean, the initial mapping activity performed by a very talented commercial enterprise that was engaged to look for the aircraft, there was a 2,000-foot difference, a 2,000-meter difference. Sorry, the American in me, I'm going standard. We need to talk metric. There was a 2,000-meter difference in the actual ocean bottom and the equipment that was deployed in order to survey. So the reconnaissance surveys of our ocean were so poor that the best informed people, including governments and the private sector, didn't realize that the water that the aircraft site suspected was 2,000 meters deeper than any reconnaissance survey. So we have work to do there. The ocean observation systems get the pulse, the respiration, the blood pressure, temperature of the patient. We have that, but not with sufficient, I would say, fidelity, because the calibration and exactness of these measuring devices is exceptional. We just don't have the abundance that we need in the sites. And then to inventory the ecosystems, as I alluded to earlier, the advent of environmental DNA and genomics sciences has really advanced to the point where a liter of seawater can be very telling. So for my investment of my time and my ambition, these are the top three that I hope we can make something happen with. So let's start with the ocean. Now, mapping by satellite has been done, and also measuring the magnetism of the Earth with ocean-going magnetic surveys, looking at the 1,500 meter pixel size of an interpolated ocean feature on the bottom of the sea. And you could see the distinction between satellite mapping and then the reality of what the bottom looks like. And going between a 1,500 meter pixel and maybe a 400 meter or less pixel is how we wind up with the definition of in-water sound-based surveys of the ocean bottom. And from this fidelity of these representations and images, we can understand where biological communities would be more likely enriched and diverse, or where they might be more uniform and less charismatic. Given that life evolved on Earth in the ocean, it's no mystery that biopharmaceutical reward has been found by looking at these maps to figure out where else to go for bioprospecting, to look for enriched ecosystems, to look for those places where our fisheries are fostered by offshore, not just inshore, but offshore waters and habitats. Important to make that distinction. Now, if we look at one of the projects that's ongoing, and Canada is very well represented in it through the Galway Agreement and also through the All-Atlantic Ocean Research and Innovation Alliance. So I appreciate the good work of our oceanographic community. The Seabed 2030 project came from largely the International Hydrographic Organization, but also the IOC, Intergovernmental Oceanographic Commission, because those two UN international bodies are responsible for the global ocean map. And the global ocean map was started in, I believe, 1908 by Prince Albert of Monaco, and it's carried on today. There are international data centers that are the repositories for ocean mapping data. But here's the real key. If you look at those highlighted areas in red, that's showing some recent activity since the Seabed 2030 project was launched. But in 2017, only 6% of the ocean was mapped. Because of this effort, today at 2023, 25% of the world's ocean is mapped. So if you look at this image and look at the light blue colors, not the gray has been mapped, the red has been more recently mapped to the appropriate levels of resolution to have an intelligent Gray's Anatomy of this ocean. But those light blue areas, which is 75% of this map, unmapped. One of the other challenges we have here is that the nations that have national security concerns because of their neighbors or because of distant neighbors are not inclined to release their own mapping of the exclusive economic zone, their 200-mile zone. So that then becomes something that we in the science community cannot overtake. It's up to the national security interests to release some of this information. But you could look at parts where east of Japan and Korea and the Philippines, there is rich mapping that's gone on there. And you look inshore of that area, and there's nothing available. If you're looking around the coast of India concerned about its national security and its neighbors, there isn't a rich release of India's exclusive economic zone. If you look in Africa, there are other parts where, because of resources, those mapping opportunities haven't been presented, and it's more a question of the availability of the technology and the capability to undertake mapping and to move. Happy to say, as we look at Canada and the United States, there's quite a bit of mapping that's been done, and it's free and it's open and it's available to the global community. So Seabed 2030 has been sponsored for the organizational investment by the Nippon Foundation. And there also are commercial interests that we need to celebrate. The multiple governmental organizations, and once again, Canadian hydrographic activity has been very, very active and supportive and shown great leadership in pursuing Seabed 2030. We've also had commercial companies like Fugro, based in Europe, and philanthropies like Caladan, run by Victor Vescovo, and Ocean X by Ray Dalio, that are mapping in an amazing level and rate, and they're depositing their information. The Red Sea, for example, recently done by Ocean X to a high degree of fidelity. So it's happening, and we just need more awareness to press on in order to get this. Tsunami forecasts dependent upon the bathymetry. If we don't have the bathymetry, it's really hard to get an accurate forecast of the impact of tsunamis, and also ocean circulation as it's changing. All right, so now let's go back to monitoring the patient to episode number 2, which is the pulse, the respiration, the vital signs of the ocean. In the lower right, I remind you that we still need Gray's Anatomy, but in the upper left, the pulse, the respiration, blood pressure, temperature. We are monitoring the ocean proudly, but insufficiently. And we need to do more, and we need to do better in order to give the kinds of forecasts that our models are capable of generating for climate and for weather. More observations, better results. We don't necessarily have to make the models better, but they will get better. So if you look now at one of the more favorable and popular components of the global ocean monitoring network, there are research ships that are deployed and making measurements. I'm not including those in this image. There are weather buoys that are offshore at a less density than what's represented here, but these are the Argo floats. Argo are those roughly 2-meter tall PVC tubes that are transiting the ocean, taken by the currents wherever they might go from their initial points of deployment. But this is a representation of the roughly 3,800 Argo floats that are deployed now. This image is about a week and a half old. Those deployments, if you recall, constitute a 10-day cycle. So every one of these floats is somewhere on a 10-day cycle of being under the water up to 2,000 meters deep, loitering for that period of time, making measurements continuously, and then with a buoyancy motor, making its way back up to the surface, and then by satellite downloading its information. So not all of these are at the surface at one time. During a 2 or 3 day period, during that same time envelope, these were the floats that were reporting in that 2 to 3 day period. So from the 3,800, you're now down to a much lesser number and much lesser density. And if you look at that here, let's just approximate the area of Canada and then postage stamp that into the North Atlantic and to the North Pacific. And you see the relative number of sensing observations for climatological and necessary measurements to feed our models. Now, again, I'm cheating a little bit because there are other weather buoys and other components, but these are the components of the system that really broke the models open in 2006, 2007, when ocean modeling really became that reliable forecasting feature. It was the Argo network. Now let's look at, and I'm sorry I don't have this for Canada, but look at that density and now see what the analogous density is in the continental United States. All these little blue dots are calibrated meteorological observation posts and climatological observation reliable data that gives the quality of forecast that we have on the terrestrial land. So we're probably not going to see the ocean surface littered with this type of sensing, but we have to be somewhere in between there and here in order to get the types of forecasts that we are capable of generating if we only had those data. The tools are available. There's an Argo float in the upper left. There is a sail drone, which is sail-powered in the upper right, and several other wind or sail-powered vehicles are under development and deployment. The wave glider in the lower right, which is a 2-piece vehicle, and the classic oceanographic research ships. So the tools are there, but we also are getting even more extravagant in recognizing that autonomous craft working as communicating team-based units can be making surveillance, measurements, characterizations of the ocean bottom and the biota, and increasingly coming to the point where we could have a laboratory chip, a laboratory on a chip, basically, and to be doing environmental analysis as these vehicles in constant communication and companionship to work as a team can be diagnosing the ocean area. So talking about labs on a chip and looking at what the biota is, the charisma of the ocean often attracts the public, but also can hold medical solutions for any number of diseases that are harming humans. As we evolved from the sea, the physiological, the genetic, and the biological components of marine organisms have common pathways to what have developed in humans. We've not really discovered the whole ocean. Venting systems, this is a white smoker. We also have black smokers. Depending upon the mineral content, we really get extravagant and we label them by the obvious color. But the venting systems and the whole hydrothermal community was really only broken open by discoveries in the late 1970s, which scientifically is pretty late. So if you look at some of these amazing life forms, I'm charmed by just the beauty, the artistry of these organisms, but they do hold biological promise. They are vital components. Each organism is a vital component of this balanced ecosystem that we have, but we are changing that ecosystem faster than we can fully measure it. This siphonophore in the top image, just wondrous in its beauty. This is not extraterrestrial life that we're looking for in space. This is right here on planet Earth. A new species of jellyfish, deep sea, down in the lower right. And by my estimation, this guy on the lower left, I don't even know what that is. And I think it's fantastic that we have things we're discovering that we haven't concluded their role, their purpose, their mission, or their speciation. Every time an exploration cruise leaves the pier, they come back with new species discovered. So now here's a concept for you. If we were to look at these species of fish on the right-hand side, which are found up west of Canada in the Alaska area, Bering Sea, our traditional method of exploring and discovering the marine biota would to be towing a fish net across these delicate silicate bodies and beautiful corals, these glass corals. So our method of sampling would have destroyed the benthic environment in order to scoop up this array of species diversity, to put those fish on deck, to count them, cut them, gut them, open up their skulls, take the otoliths out to age them. Classic fishery science. But we would have destroyed the environment that they depend upon. A better way, an easier way, is to accelerate the use of environmental DNA, because every organism, humans, whales, bacteria, even the bacteria that's in the belly of the whale, is evident and sheds its DNA in the ocean water. A 1 liter sample can easily lead to an inventory, a competent inventory of what biota is in the ocean. So encouraging our nations, the DFO and for the US, the National Marine Fisheries Service, working diligently to try and close these gaps. But right now, there's enough money to run your surveys. There often is not enough money to do the beta testing and beta development of the new methodology to bring in alongside of the traditional methodology of towing a net with a research vessel. I did that for many years. I did that alongside of our Canadian colleagues from DFO up on Georges Bank as we would do comparison trawls together. But the use of this environmental DNA is the coming wave, and it's just ripping open the opportunities for the inventory of the marine system. More work to do here. I've listed several programs on the bottom of this slide: Marine Life 2020, the MBON, et cetera, Deep Ocean Observing Strategy, and Ocean Census. These are activities that are part of the UN Decade Program and can be joined just with the willingness and the intellect. You don't need dollars, you don't need money in order to help move this along. But these are 4 of the more progressive programs that are trying to move this forward and to get a competent inventory of the biology of the ocean and to understand the interrelationships of that complex ecosystem fast as it is changing. All right, now let's talk about telecommunications cables. They're everywhere. They allow us to transmit our internet, our data. We're probably working through marine telecommunication cables right now at some point throughout this distribution. And we have an opportunity here, and the program is called the Smart Cable Program. It's based on 3 UN organizations working together. WMO proudly represented in there, along with the International Telecommunications Unit and IOC. But the challenge that we have is that the cable industry and the people who are paying to install cables are very narrow in their focus. Cables are expensive to deploy. And the deployers and the owners, the sponsors, aren't terribly interested in any distraction other than to just get that cable in on schedule, on budget, and at cost in order to avoid any distractions. But with the learned opportunities that are being developed now by some of the commercial companies that make cables, I want to show you that both the Portuguese and the French are committed to installing smart cables, putting these nodules, these nodes on the cables that also collect environmental information so that we could be, number one, watching the ocean temperature at a daily basis and know exactly where and how the ocean currents are redistributing heat and how that ocean temperature is changing. It is changing. We know that. Argo has taught us that, and Deep Argo has taught us that. But these cables would give a long-term in situ measurement rather than the floating and almost distributed by the currents nature of what Argo is. But now I look over at one of the greatest users of internet, both in dollar wealth and in transmission of information. And I see that Google has announced the installation of 5 cables across the Pacific Ocean. Now, the Pacific Ocean is red hot. It is a dynamic zone. It is capable of generating the kind of geology that sponsor tsunamis. And wouldn't it be nice if the Google folks, who also have interest in ocean science through the extension of the Schmidt Ocean Institute, if those 2 parties could put their minds together and basically make these new cables smart? And I would assert that doing so would be very smart. Not doing so is not very smart. We have an opportunity here. We need to be pushing this, and the Smart Cable Program that the joint task force that's been organized under the UN Decade of Ocean Science is one such way to do that. So I'm going to draw to a conclusion here after that blunderbuss to just recap by saying the UN Decade of Ocean Science has, I'm sure, just about whatever you're interested in, including those air-sea interactions, that atmospheric-oceanic interaction, the ability to improve our models, to make those models better and have better climate forecasts. It also has a lot that's in the ocean that moves to it. But some of the ongoing activities here I'll mention. The UNCLOS, the UN Convention on the Law of the Sea. That treaty has been around since 1983. The United States has not joined that. It's a political football that is never going to be fully inflated. But the need to be addressing the law of the sea is brought upon us by this changing Earth. There are components in that international body or in that treaty that really need to be addressed. I think we can all be pleased that we've recently seen the text for a treaty that comes under the law of the sea, the Convention on Biological Diversity Beyond National Jurisdiction, or this BBNJ that I've referenced here. The text has been written. It's an instrument that's open for not just signature, because 83 nations, I believe, have 81 or 83 nations have signed already their intent to join. But under international law, the intent is not good enough. The instrument then comes in force. The treaty comes in force when 60 countries have signed and implemented. You have to implement domestically so that your citizens are responsible for following those directions. But the BBNJ text has the sharing of genetic and biological resource information so that those countries with lesser economies can have some measure of value in what is viewed upon as the common heritage of humankind. Law of the Sea, a very dated and male-dominated world at the time, cited the common heritage of mankind. BBNJ, organized under the Law of the Sea Treaty, is referencing the common heritage of humankind. More appropriate, of course. I'll mention, and we could spend a lot of time on, but don't have that time available, the 9-dash line, this rather spurious notion that's coming from China to redefine what the law of the sea has settled for decades, which is the jurisdictional basis of a land-based country's reach into the ocean. But these notions that are spurious and already been disproven in international arbitration and courts seem not to have quelled the ambition of China to go ahead and proffer a renewal of the thinking or a change of the thinking in ocean geological space or geospace, and it's just not founded in law. But that's a stunning international problem that we have to address and deal with. Marine scientific research, MSR, the definition in the law of the sea is rather amorphous, and we struggled for 5 years in the IOC, and now we're teamed with WMO in working on global observations through Argo. But the deep Argo and the biogeochemical Argo, we wrestled with as to what the methodology of deployment and how coastal states would or would not accept these floats coming in with the currents into their EEZ, and whether or not that constituted marine scientific research. It took us 5 years to settle that issue. It is settled. The floats are welcome. Some countries just require advance notice that the float is forecast to come into their region, but the information is collected and distributed. Now, I mentioned WMO and IOC. I think these two organizations have, in a very timely way, brought themselves together and have really matured with the simplicity of organizational design in order to be sponsoring, co-sponsoring, collaborating on these ocean measurements that feed into weather forecasts and also enrich our understanding of the oceanography. I think that's going well. We have new faces and new people coming in cycles of election for both IOC and WMO. And I think the membership is excited by these opportunities, and we look forward to continued progressive seasons there. And once again, I want to give my congratulations and appreciation to the Canadian delegation at IOC, with whom I worked very closely with for my 11 years. Ocean observations need to mature. They need to get more finite. And by the way, as we start talking about the changes in the ocean itself, it's by these systems that I showed you with some illustration here that we need to amplify. They will improve the models. Those models will enhance our ability to promote and enjoy a blue economy as things develop here, with more information, better forecasts, greater reliability, and earning benefit from a sustainable economy that can be with the ocean in mind. Climate change is upon us all. Need not mention that further. MCDR is marine carbon dioxide removal. We have a lot of carbon dioxide in the atmosphere. We have a lot of methane in the atmosphere as well. Removing carbon dioxide, and perhaps not enough attention on removing methane, but that's a whole nother discussion for another day. But removing carbon dioxide from the atmosphere and the ocean is what the ocean does every day. Remember that diagram I showed you earlier. It's not just the trees that commence photosynthesis, but it's also the plankton, it's the cyanobacteria, it's microbes that are in the ocean that are producing oxygen and absorbing CO2. But as we start to look at methodologies of ocean fertilization, the genesis of the depositing of hydroxide ions to lower the pH of the world ocean, kind of like a giant Pepto-Bismol tablet in order to take the acidity out of the ocean, or putting iron fertilization in the ocean to promote photosynthesis because it's a limiting element in that cycle. We're not going to know how well this works. We're not going to know whether this is harming the environment or not without an observing system that's suitable. And I was with a group of financiers recently, and Anya Waite, once again, to sing Anya's praise up at the Ocean Frontiers Institute. Anya is working hard to get a North Atlantic carbon measurement system employed so that we could be looking, at least in the North Atlantic, does this stuff work? How much is it changing? But right now, without such an observing system that's focused on these attributes, you might as well be investing in environmental Bitcoin as opposed to carbon sequestration credits for ocean-based, because we don't know the totality of how much carbon is in the ocean in order to say we're reducing that amount by what percent. More observations would solve this. And then lastly, exploration. 95% of the ocean remains unexplored. It's not just the map. 25% now is mapped and available to the public to see. But the 95% that's unexplored looks at the biota, looks at the changing ecosystems, looks at the geology, chemistry, biology, etc., and a marvelous submerged human history in marine archaeological resources as well. So folks, we have a lot of work to do. The UN Decade of Ocean Science is helping us along to do this, and it's going to bring an advancement to so many things that we're looking at. But what you're looking at right here is my wonderful 8-year-old granddaughter. And for me, she is my motivation. I work for her. And when I think that she understands what grandpa does a little bit, as she gets older, she'll understand a little bit better. And I say this to many people, and I mean it from the heart. I don't want her to look back and say, why didn't the old man try harder, when she winds up living in a world that looks more like a Mad Max movie set. We're changing this earth too fast, and we owe it to our youngsters and our younger generations, and even her kids, to leave them with something better than what we've created. So thank you very much. I appreciate your time, and thank you for enjoying my family photograph. But I will conclude with that, and I'll take any questions that you might have. Thank you. And David, thank you again for the opportunity.
Well, thank you, Craig. That was a great talk. We have a few questions. First was from John Gilbert, and he said, like, what a fabulous talk. But he'd like you to comment on the UN Sustainable Development Goals. You outlined that in the beginning, the relationship between the UN Decade for the ocean and the Sustainable Development Goals. He goes on to say they were set in the 1990s, and even then they were, to many of us who felt that they were far too optimistic. And so what is the role and potential of science in making sure that goals in future are realistic and achievable? So it's kind of setting a better context for goal setting in the UN, let's say.
Yes, indeed. Thank you, David. And John, thank you for the question. I appreciate your compliment. Thank you. I think your characterization is entirely accurate. And in looking at how the UN, where one has to, by consensus, get agreement from the body in order to go forward with any attribute that is underpinned and endorsed by the UN, it's a consensus agreement. The idea of being overly optimistic reminds me of the IPCC. I think as we read the IPCC and we see that there is some reticence to be accused as sounding like an alarmist, the IPCC characterizations always leave that prayer and that hope that we're going to beat 1.5. And I think as we look, yeah, mathematically possible, humanly improbable. Back to the human improbability. Early on in the planning of the ocean decade, and John, recognizing just what you recognized, that the sustainable development goals, number one, need to be revisited. They are outdated either by optimism or by, in some cases, not pushing hard enough in order to really underpin that urgency. But at one of our global planning meetings, I think it was actually a regional planning meeting, one of the gents that was there pushed himself back from the chair, which was huge body language of almost resignation, but not resignation from the process, but just mentally saying, his comment was, why do we need more science? He knew we did, but the point was, we know what we need to do. And it's not always the science that is our gap. It's the political will and the commitment of nations in order to follow these paths. So I think the challenge of getting the more ideal and what we as a science community of developed nations might agree with, having to work through consensus to get the approval of others and the whole body is where that challenge comes from. But I think that the sustainable development goals need to be updated, and they need to be updated with a realistic focus and also, in some cases, greater sense of urgency. Thank you.
Yeah, thanks. Thanks for that that answer. John Stone, he posted a question, and could you say something about the industrial harvesting of ocean bed resources?
Yeah, John, I think maybe what you might be leaning towards is, obviously we have commercial fishing, and that's benthic harvesting, also midwater harvesting. We have the opportunity to be putting in maritime or marine aquaculture. But the greatest concern right now in the environmental community is deep seabed mining. It's also a concern in the economic community, because China, there were some recent articles in the lay publications that point out how China has been pursuing the development of marine harvesting of rare earth metals. And for our electric cars, our redesign of the power distribution system on large continents are dependent upon these rare earths, as are our batteries, et cetera. So looking at the environmental disruption versus the gain to society is a balancing act that is not necessarily, in my opinion, is not necessarily going to be guided by the precautionary principle in all cases. Depends on the country. So the disruption of the seabed in order to harvest and collect mineral deposits, or even to grind down extinct and hopefully not active hydrothermal events, because there's so much marine life on those hydrothermal events that we don't understand yet, some of which have been shown to be medically active and medically beneficial for humans. So taking that precautionary approach is wise. I'll note that in the BBNJ, in that biodiversity beyond national jurisdiction, there's a requirement for those nations that sign on an agreement that there'll be an environmental assessment performed before any disruptive activity is undertaken on the seabed. That's probably more than idealistic. That's probably going to be a reality practiced by those countries that choose to sign. But it's something that we need to be doing everywhere in the earth. And I know there's Canadian law similar to American law where one has to consider the environmental consequences of the action that at least a government might take before that action is taken. And to have that as an international instrument in a treaty is very beneficial. So will it work? It'll probably slow the demise of our environment if it's fully implemented, but I think it's very important for us to do. And it's very important for us to understand the environmental consequences, whether it's marine carbon dioxide removal, whether it's deep seabed mining, and then look at what is the gain that society is going to realize versus what is the cost to society. And some of those costs can be long-term and not immediately apparent. So that's where science will inform us as to the value of those propositions. Thank you.
Thanks. Thanks again. Another question, and this is from Len Berry, who is our chair. He's just wondering why the Gulf of Mexico is listed as unmapped on your global coverage map. You know, the map you showed us of the areas that were there. So maybe you could just clarify.
Yes, Len, thanks. That's a really telling invite and an opportunity. The Gulf of Mexico has been mapped, but it's not in the public domain. The oil companies that are producing from the Gulf have mapped it quite sufficiently. And one of the hopes that we have through Seabed 2030 is twofold. One is the oil companies would be mapping at a degree of resolution that is beyond what Seabed 2030 would request and is beyond what the science community would absolutely need in order to prosecute the intellectual conclusions we need about the bottom of the Gulf of Mexico. The amount that governments have mapped and that academia has mapped are minuscule. The Gulf of Mexico itself is, if the maps that industry holds can be degraded in resolution and then made public, by tomorrow morning, the entire Gulf would be mapped. The second shoe to drop on this one would be, what's the benefit for industry to do that? Is it kindness of heart? Is there some VP in the corporate structure that has an environmental portfolio and wants to be seen as a responsible community steward? Well, maybe the answer is in just getting a simple statement from the Treasury Department and the analogous bureau or body in ministry in Canada that basically says, we desire to map our EEZ. We desire to map these oceans. You're doing it for us. Here's your tax benefit for the donation of your data that allows us not to have to spend public money to do just what you gave us the data on. So there are opportunities there, but the amount of the Gulf of Mexico that's government mapped and freely available versus the proprietary as it's seen by the commercial companies, we could turn that on its ear if we just had the willingness of these commercial enterprises to work a little bit with us to do it. Thank you.
Yeah, again, thanks very much for that response. I have a question. You know, in the Argo map that you showed, and you're kind of basically understanding the sort of the 3 dimensions of the ocean. Well, really, it's 4 if you add time. But the 2 areas that are not on there is the Arctic Basin, you know, and obviously, you know, it has ice, and I thought you might want to comment on it, but the Southern Ocean also seems to lack. And of course, the Southern Ocean is always thought of as being critically important to, you know, marine ecosystems, you know, rich in their food sources and things like that. So I'm wondering if you could speak to, you know, how the UN decade for oceans is looking at those two regions, which have been fundamental gaps in our understanding of the ocean.
Thank you, David. Certainly for the Northern Hemisphere, same for the South, but certainly as the Northern Hemisphere watches the Arctic break up, and what was a rather concise circulation is now dissipating as it warms. It is warming faster than any models have forecast. You can look at all of these things, and as it warms and as the jet stream diversifies in range, we're seeing different weather than people had normally seen. There's a lot going on in the Arctic, and it's remarkably underobserved. The programs in the UN decades that are polar in nature are, I would say, somewhat orphaned in terms of the investment by countries that don't have an immediate interest in the Arctic. Every country should, because every country is going to be impacted by the weather and climate effects of the changing poles, both south and north. The southern situation is tough because most of the global money is in the Northern Hemisphere, and the countries that are local, other than New Zealand, South Africa, and Australia, there's not a lot of activity undertaken there. Some of the South American countries are increasing in contributions, and I don't want to miss the opportunity to recognize that. But the poles are the orphans. I remember when I first came into NOAA as a young ensign, and I was given career advice of take substantive assignments that are going to be growing for your career opportunities. Okay, that was good advice. But the comment that was made was, don't go after the suntan assignments, tropical islands, checking on gear that's deployed in the warm weather areas, et cetera, which I never did have a suntan assignment. But that always stayed with me, and I realized, where does most of the science take place? In the amazing environments of the tropics or the semi-tropics. That's where people want to go and study. They want to be marine biologists to put the tank on, go underwater and look at corals. Not put on a parka and slug it out up in the Arctic. But I was just up in Greenland, and I'm watching that ice melt, and it was absolutely stunning as to how fast things have changed up there when you look both at the satellites, but then also local photographs to see where the glaciers had been and where they are now. And I realized that's an area that we're not paying enough attention to. The not even paucity of observation platforms, David, the lack of observation platforms in the poles. Yeah, we have Antarctic research stations, but we don't have enough around the Southern Ocean. We don't have enough in the Arctic Ocean. We need attention to the Arctics, to both Arctics, North and South. And when we see governments making choices, usually we're spending money. The United States just had 2 large slugs of money for climate-related activities under the Biden administration's call. And most of it is going domestic U.S. coastal resilience. We're shoring up our vulnerable areas to the extremes in weather that we know are coming and have arrived. We're not spending enough money on the Arctic. We're not spending enough on the Antarctic. So it's the orphan. I think we need more. If we get more down there, we won't be able to say that the most rapidly changing by temperature place on Earth is least understood, least monitored, and most poorly forecast. We need help there.
So I guess I'm finding some way of connecting the fact that things that are taking place in these polar regions are having significant consequences on life, both in the sea and on the land, you know, and trying to enhance that, because I have to say, from my own vista, I would say that if we don't start addressing and understanding these changes, we really won't understand the dynamics that are taking place in the ocean, and you know that'll be missed. But we're kind of
I agree.
I don't see any other questions. Like, some people are coming in and saying excellent presentation, they really enjoyed it. I have to say that's probably a consensus view that you did. It was fabulous to take the time and talk to us. It's recorded, and the advantage of having it recorded and posted on YouTube is all those who are having trouble being able to get in this time slot will follow up with the YouTube presentation, so they'll be able to see that. And of course, that value is we track how many go-tos we get. So I'm sure this will be one of the significant go-tos when we do our tracking. So thanks again, Craig. Really appreciate you taking the time. Great to see you again. I only saw you last week, but great to see you again. And I appreciate taking the time on behalf of CMOS. Talk to us. Fabulous.
Well, thank you,
Thanks
David,
so much.
and thanks to everyone. Thank you all. It's a pleasure to be with you. Good luck.
Okay.